Okay, so if we were asked to simplify this as a fraction, it's a bit weird for us to see fractions within fractions. Okay, it's something that we're not used to seeing. So before I start, what I'm going to do is, I'm actually, funny enough, usually you guys see me, if I have a division, write it as a fraction like this. Okay, but actually I'm going to change this to just being a division sign. Okay, so it's everything in the numerator being divided by everything in the denominator. So I'm actually going to rewrite it like that. Okay, so I'm going to say that it's a 1 minus a 3 over x minus a 10 over x squared. And that's all being divided by what's in the denominator. Okay, so it's all being divided by a minus 1 plus 2 over x and plus a 15 over x squared. Okay, now we know our rules for dividing by fractions, okay, but we want one full big fraction in here, one big fraction in here. So let's go up to what we had in the start of our simplifying fraction stuff. Okay, when we have different denominators and they are adding or subtracting, the first thing we're doing is we're looking through these at how can I get a common denominator. Okay, once we have a common denominator, we can put them all over that same denominator. Okay, so here we need to look at this in the first bracket. Okay, so if I want to do these subtracting this and subtracting this, I need to get a common denominator first. Okay, so my common denominator here, well, this is a 1, this is an x, and this is a x squared. Okay, so the easiest denominator, the lowest common denominator that I can add in there is an x squared. Okay, if I make all the denominators x squareds, now they are common. So this denominator here had to be multiplied by an x squared, which means the numerator also has to be multiplied by an x squared. And this denominator here had to be multiplied by an x, which means this numerator also has to be multiplied by x. Okay, it's the same thing over here. Lowest common denominator is going to be an x squared, which means the numerator has to be multiplied by an x squared, and the denominator over here has to be multiplied by an x, which means the numerator over here needs to be multiplied by an x. Okay, so now for me to go on to my next line, okay, I can write them all over the same denominator. So I have an x squared minus a 3x minus a 10, and that is being divided by all over one denominator, a minus x squared, a plus 2x, and a plus 15. Okay, and that's all over x squared. Now, you might spot at this stage ways to start simplifying these. Okay, but if not, it's fine. Remember our rules. We actually prefer dividing in fractions than adding and subtracting in general, because we don't actually have to go and find a common denominator. Okay, so the thing that's really nice about division in fractions is it's almost as easy as the multiplication. Okay, in multiplication, it was top by top, bottom by bottom. Okay, so in division, what we're going to do is we are actually going to change it to multiplication, and we are going to simply flip this second fraction upside down. So I'm going to have an x squared, and I'm going to have a minus x squared plus 2x plus 15. Okay, so now I can do my multiplication rules with this. So top by top, bottom by bottom. Okay, so the other thing I will say is we need to know, remember in our multiplication in fractions, okay, actually not even in multiplication in fractions in general, we can cancel something on the top line and bottom line if it is multiplying both the full top line and the full bottom line. So I'm really looking at this in terms of, okay, well, what is on the top line? Okay, I want to break it down into everything that is multiplying together to give me that top line. That way I'll be able to say, oh, that's multiplying everything on the top line. Okay, so I'm going to split this up into what's multiplying together. I'm not going to actually multiply them. What I'm going to do is I am going to see what is multiplying together to give me this part. Okay, so I'm actually going to factorize that on the top line. Okay, I want to see, for example, if I had something like 6x and 9y. Okay, to simplify that, I would want to see, well, what is multiplying both lines? Okay, I would say, okay, there's a 3, so I'm factorizing out. Okay, I'm saying exactly what is multiplying together to give me that top line. It's a 3 by a 2 by an x, and on the bottom line, it's a 3 by a 3 by a y. So I'd be able to cancel those 3's there. Okay, so that's what I'm going to be doing in this. I'm not multiplying those out, I'm actually factorizing. Okay, I'm splitting them up even more so that I can see what is multiplying to give me the top line. Okay, so with that being said, you can factorize on this next line or you can just copy it down. Okay, so this one, that's a nice one line factorizing question. Okay, I'm having a leading coefficient here of 1, which means it's a nice quick factorizing that I can do. Okay, I can say what multiplies together to give me minus 10. Okay, so it's multiplying to give me a minus, which means the signs have to be different. So I might have something like a minus 5 with a plus 2. Okay, they're also adding to give me a minus number, which means the greater number is going to have to be a minus. So this actually works out. Okay, minus 5 and 2, they are going to add to give me the minus 3. So I'm going to write that down as x minus 5 times x plus 2. Okay, if you don't understand that, you need to go back over our factorizing stuff. And then we have an x squared in there. Okay, and then on the bottom line, I have an x squared. And then over here, if I want to factorize this, its leading coefficient is not 1. Okay, but I could very easily make the leading coefficient of this the number 1 because it is just a minus 1 in front. So if I want to change the sign, I can change the sign of all these. Okay, I can technically factorize out a minus 1 there. Okay, so I'm going to factorize out a minus 1 so that I can rewrite this as an x squared minus 2x minus 15. Okay. Now this here in green is something that I can factorize easily. Again, its leading coefficient is a plus 1. So I'm going to list out my factor pairs for minus 15 that add to give me a minus 2. Okay, so I'm going to continue on to factorize this. Now, a few things here. Okay, I now have an x squared multiplying the full top line and full bottom line, so I don't need to bring those down, they can cancel. Okay, I have a minus 1 on the bottom line. Okay, if the denominator is a minus, that's just the same as one big minus outside the fraction. Okay, so I'm going to write this as a fraction. Okay, but I'm going to take that minus out and I'm going to write it outside the fraction there. Okay, so the top line has x minus 5 by x plus 2. Okay, then the bottom line. So the minus 1 on the bottom, I have now just brought outside the fraction. Okay, it's like a plus 1 over a minus 1 gives me a minus. Okay, then this, if I want to factorize that further, okay, I'm going to have an x in my start of my two brackets. I'm going to have a minus 5 in one and a plus 3 in the other. Okay, now if we look, there's an x minus 5 multiplying the full top line and full bottom line, so that can cancel. So I will be left with a minus x plus 2 over x plus 3. Okay?